Hello, Cedar Crest Chargers. This is the tutorial video for Advanced Math 48, our very last assignment. So it's with heavy heart that I do this video, and I wish all of you a great culmination of your year, a great summer, and I just wish the best for you for high school. And so I want to thank you for being amazing kids for me this year. We're going to go ahead and do a video on some problems that, some problems that you're going to have to do, and I'd like to provide examples for you so that you don't have problems. There's a couple problems here that we're going to do. We're going to do A. We're going to talk about what this literally means, and believe it or not, A and B have the exact same answer, but for different reasons, and we'll talk about that for a second. The first one is the cubic root of -8, okay? That is relatively simple. We are trying to find the number, the base. You can do this just in your head normally, like what number times itself 3 times gives you 8, or in fact -8. You could use a calculator on this, but really what we're asking is what number repeated multiplication 3 times. Is it 1 times 1 times 1? No, that's silly. We know that's 1. But 2 times 2 times 2 is 8. So the answer to this is, the answer would be a form of 2. But the question is, how do we get the -8? And I think that if you really think about it, it's -2. -2 times -2 times -2 gives you the -8. So the answer here is, right, -2. All right. The second one over here, I guess we'll do this in red. This is B. This is technically asking something different. You'll notice that the minus sign is at the end. That is the very last thing that we're going to evaluate. That's the very last thing we're going to do. What we're going to do is figure out what this is, and then in the end, we're going to reverse whatever sign it is. Okay, that's what this does. So it's going to be positive. Like before, we know that the cubic root of 8 is 2. We know that 2 to the third is 8. And then that's a positive number right now. But then when we apply this, then it makes it negative. Okay, so the answer here is -2. All right, but for a very different reason. Both answers are the same, so we've evaluated both of those expressions. The next one is it looks rather complex. I'm not going to lie to you, it is rather complex. It has a lot of steps, so let's just talk about what the first step is. The first step is understanding that there is a power on the outside, and we're going to elevate, or we're going to raise every power on the inside of the parentheses times 4. So I think it's important to note that the 2 here, the base, has a power of 1, and the 3 has a power of 1, and the x has a power of 1. And I always, that's probably a good practice to do, because now you know that you have 3 bases to raise to the 4th power. There is a base here, there is a base here, and there is a base here, and there is a base here, and a base here, and a base here. There's 3 different bases, and so what that means is that we're going to multiply all of these powers times the 4. So let's go ahead and do that, all right? 2 to the first, the rule is that when we do a power of a power, we are multiplying our powers together. So 2 to the first raised to the 4th power becomes 2 to the 4th. X to the -2 times x to the positive 4 is x to the -8. And then lastly, y to the 3rd raised to the 4th power becomes y to the 12th power. So really, this looks really daunting, but it's not. Really, all we're doing is multiplying. But don't forget to do the same thing to the bottom numbers. We're going to multiply that 4 times that -4, times that 1, and times that 1. So we end up getting 3 to the 4th. We end up getting x to the 4th. And we end up getting we end up getting negative y to the negative 16. Okay, now that's most of the work, but the next thing that we need to do is rewrite this using positive exponents. You don't really want to have this problem with negative exponents, okay? There's a very simple trick. In order to get rid of a negative exponent, you would take it from where it is and move it up or down. For example, if you had 1 over 2 to the negative 2, if you take that and you want to make it a positive exponent, you just move it up top. So it becomes 1 times 2 to the positive 2. That's the effect that it has. That's a shortcut. We learned that a long time ago. So in this problem, I'm not going to go over exactly why. I don't have time in this video. We've done this before. I've taught this before. So what we're going to do is we're going to find all of our negative exponents, right? Our bases with negative exponents. And we're going to move them up or down, okay? So here's what this becomes. 2 to the 4th stays the same. X to the negative 8 goes down, okay? All right? So what it becomes is it becomes x to the 4th times x to the positive 8. Okay? That's what it becomes. That's what happens with your x's there. Okay? So that becomes x to the 12th on the bottom. X to the positive 12th on the bottom. Okay? All right. And then the y to the 16th goes up, and it becomes y to the positive 16th. All right, and when you multiply those, that becomes y to the positive 28th power. All right, so the y's are done, and then you really just have 2 to the 4th and 3 to the 4th. And if you want to simplify those things, then we can go ahead and do that. 2 to the 4th, 2 times 2 is 4 times 2 8. So that's 16. 2 to the 4th is 16. Y to the 28th power. All right. And then 3 to the 4th is, I believe, 81. 3 times 3 is 9. Times 3 is 27. Yep. So 3 to the 4th is 81. X to the 12th. And that is how you would simplify that problem and go from where it was to where it needs to be. And then lastly, I want to talk to you about evaluating expressions with rational exponents. I want to use a little logic here. So please understand that a 3/4 power is less than 1, right? We know that 16 to the 1st power is 16. So hopefully it's logical that when your power is less than 1, your answer should be less than 16. Right? Just like if we would expect, as that power is bigger than 1, we would expect our answer to be much bigger. So I'm going to share with you how you do that. This is 16 to the 3/4 power. So we're breaking this down into 2 problems. So 16 to the 3/4 power. This denominator literally means 4th root of 16, and that's where we're going to start. We would write that as, what is the 4th root of 16? What number to the 4th power is 16? Now you can also do this in a calculator. 2 times 2 is 4, times 2 is 8, times 2 is 16. Basically, what happens is that that 16, the 4th root of 16 is the number 2, okay? So once you do that, right, okay, that's great. And then this is, you raise that to the 3rd power. You raise that number to the 3rd power. And so our answer is 8. Let me break this down another way for you, okay? So the answer to this one is, in fact, 8. I'd like to show you another way. I'd like to break 16 down into its prime components, okay? So 2 times 8, 2 times 4, and 2 times 2. In other words, 16 is 2 times 2 times 2 times 2. There are 4 of them. You see that? The 3/4 power means that we select 3 of the 4. That's 2 to the third. That's another way of looking at it, right? I kind of like the way before because it works all the time and it works, right? So let's reiterate, right? This is the 4th root of 16, which is 2, and then it's 2 to the third power, which is 8. And then we'll do the same thing to 27. It's 27. It's the 3rd root of 27, right? Okay, so what number? It's 3. 3 times 3 is 9, and 3 times 9 is 27. So the cubic root of 27 is 3, all right? And then we raise that to the 4th power. This one's going to be bigger, isn't it? It's going to be bigger than 27 because 4/3 is bigger than 1, all right? And so that's 3 times 3 times 3 times 3, which happens to be 81. So what we're saying is that 27 to the 4/3 power is 81. It's a bigger number. Yeah. Chargers, I hope that that helps. I bid you a great year and a great summer. And if you haven't already done so, go ahead and get all of your missing assignments done. Peace out, Trout.